Imagine watching reality collapse into a dream. A wine glass slips from your hand, shatters across the floor, and then, impossibly, each fragment leaps back into place. Splinters fuse into wholeness, vibrations retreat into silence, and what was broken stands pristine once more. The universe itself seems to inhale, pulling chaos into order. Stars, instead of burning out, surge with renewed brilliance. The fabric of time tightens, reversing its threads. What would you call such a vision? A miracle? A nightmare? Or the answer to the most forbidden question in physics: can entropy run backward? The second law of thermodynamics is more than a technical principle hidden in textbooks. It is the silent ruler of our lives. It whispers that disorder always grows, that energy dissipates, that ashes will never leap back into flame. Every moment you age, every star that dims, every memory that fades into the dark is a tribute to this law. It is the reason ice melts, the reason batteries die, the reason galaxies spread into shadows of what they once were. Entropy does not negotiate, it commands. And yet, what if it could falter? What if this universal decree was less a law and more a fragile condition, one that might be bent or even broken? This possibility lingers like a phantom behind physics, a thought so dangerous that even entertaining it feels like treason against reason. To ask whether entropy might retreat is to question the very arrow of time, the direction that defines past, present, and future. Entropy is more than mathematics, it is memory itself. We remember the past because it is ordered. We anticipate the future because it is destined to unravel. The arrow of time exists not because clocks tick, but because disorder advances. The cracking glass cannot spontaneously repair because probability locks the door. There are countless ways for chaos to increase, and only a single narrow path for order to remain intact. Nature, following numbers more than intention, marches downhill into multiplicity. Entropy is not simply a tendency, it is the story of existence written in statistics. But what if statistics lied? What if, hidden within the apparent inevitability, there was room for reversal? Imagine a universe where the tide of disorder suddenly ebbs instead of rises. Molecules align, heat flows from cold to hot, memories unspool backward. Your last breath becomes your first. Civilizations unravel into tribes, tribes into lone wanderers, wanderers into stardust, drifting into hydrogen, clouds. And finally, all of history collapses into silence before the Big Bang reassembles itself into a singular point of impossible purity. Is this fantasy or a possibility encoded into the very logic of physics? The scientific mind recoils. No, it insists. The second law is unbreakable. It is the foundation of thermodynamics, the bedrock upon which engines, chemistry, and cosmology all rest. And yet, the forbidden question persists. For while entropy's increase is overwhelmingly probable, probability is not certainty. To say that disorder always grows is to exaggerate. What the law truly declares is more subtle, that disorder is favored overwhelmingly, irresistibly, but not absolutely. There remains, hidden deep in the equations, the faintest margin for rebellion. Consider a deck of cards shuffled endlessly. The odds of them arranging into perfect numerical order are microscopic, but not zero. Similarly, the particles of a shattered glass could, in principle, ricochet into the exact pattern of their former shape. The heat dissipating into a room could, in principle, rush back into the coffee cup it abandoned. These events are not forbidden by physics. They are simply imprisoned by improbability. The chains of chance are so heavy that their escape is never seen. Yet theoretically, they remain. And herein lies the tension that makes entropy so haunting. It is both absolute in practice and fragile in theory. The entire fate of the cosmos depends upon a law that could, in principle, fail at any moment, and yet never does. Why? What preserves the forward march of time? What keeps probability from rolling the dice in reverse? This paradox gnaws at the heart of science and philosophy alike, for if entropy can never run backward, then time itself is a one-way street, carved by necessity. But if it could, even once, then the universe would not be bound to progress from order to chaos. Instead, reality would hang in a trembling balance, always teetering between collapse and reversal. And if that were true, then the meaning of existence, from the aging of our bodies to the death of stars, would be suspended over a question mark. Physics insists on pragmatism. We do not see shattered glasses reform. We do not see smoke leap back into logs. Therefore, entropy is safe. But the philosopher is less easily silenced. Why should time flow in one direction at all? Why should the future differ from the past when the underlying laws of motion make no distinction between them? Whether Newton's mechanics, Einstein's relativity, or Schrödinger's equation all run just as easily backward as forward. The universe, on its deepest level, does not seem to care about direction, yet our lives are chained to one. How is this possible? It is here that entropy becomes more than science. It becomes metaphysics. The arrow of time emerges not from the core laws of reality, but from boundary condition. At the birth of the universe, matter was arranged in improbably low disorder. From that improbable beginning, chaos had room to expand. In other words, entropy's tyranny is a consequence of the past itself. If the cosmos had been born in chaos, we would know no arrow. Instead, because it was born improbably ordered, the universe cascades into disorder, carrying us with it. The second law is not so much a commandment as a cosmic inheritance, but inheritances can be betrayed. What if, deep in the cosmos, there exists a pocket where the arrow of time runs differently? What if regions of space-time reverse, memories, collapse into futures, and what we call before and after exchange places? Some cosmologists speculate that black holes, or even the universe beyond our horizon, might obey strange temporal symmetries. Others whisper of a cyclic universe, endlessly reversing its entropy, collapsing into order, only to explode again. In such visions, the second law is not absolute but local, a rule that governs our patch of reality but not all of it. And then comes the existential sting. If entropy can reverse, then so can life. Consciousness itself could untangle, unwinding into innocence rather than dissolving into death. Memory might drain backward through the corridors of time so that the last thought you have is the first thought you ever formed. Existence, instead of ending, would spiral into its own origin. Is this salvation or oblivion? The forbidden question does not yield answers. It lingers like an echo in the halls of physics, daring us to ask what lies beyond the comfort of inevitability. Can entropy run backward? We cannot prove it, yet neither can we escape the possibility. The arrow of time feels absolute because we have never witnessed its betrayal. But absence of evidence is not evidence of absence. Somewhere, perhaps hidden in the folds of the cosmos, the improbable may already be happening. Somewhere, perhaps, glasses are unbreaking, stars are reborn, and time itself flows in retreat. And so we are left with tension. Science demands certainty, yet entropy offers only overwhelming odds. The forbidden question tears open the boundary between physics and philosophy, between what is known and what is imagined. If entropy defines existence, then to doubt it is to doubt reality itself. But perhaps in that doubt we glimpse the deeper mystery. Perhaps time's arrow is not a law, but a story, one the universe tells us to keep order in our minds. And stories, unlike laws, can change. What happens if entropy betrays us? What happens if the arrow turns? The answer remains veiled, as it must. But the question, the forbidden question, is what draws us forward, or perhaps backward, into the heart of the unknown, entropy and the arrow of time. Picture a candle burning in the darkness. Wax melts into liquid, liquid drips downward, flame devours fuel, smoke coils upward and disperses into air. Every flicker of fire is a translation of order into disorder, of potential into exhaustion. You can watch the wick collapse, the light dim, the air thicken with ash. But you will never watch that smoke condense back into wax, never see the flame restore itself from ashes. The candle burns forward, always forward. This is entropy, not as an equation, but as lived inevitability. Entropy is one of the most powerful concepts in physics, yet it hides behind a veil of abstraction. Thermodynamics defines it as a measure of unusable energy, a quantification of how much work a system can no longer do. Statistical mechanics sharpens the picture. Entropy is the number of microscopic arrangements that correspond to a macroscopic state. In simpler terms, it counts how many ways disorder can prevail. A glass of ice water can exist in far fewer microstates than the same glass once the ice has melted, and therefore the melted state is astronomically more probable. Entropy is the mathematics of probability expressed in matter, energy, and time. The second law of thermodynamics, the law that ties entropy to time, is not a law of absolute prohibition. It does not declare that order can never increase. Instead, it states that in a closed system, entropy tends to increase. That word, tends, hides the secret of the universe. It is a law not of necessity, but of overwhelming likelihood. The odds that heat will flow from cold to hot are so staggeringly tiny that we never witness them, yet the equations whisper that such improbabilities are not impossible, and so entropy is revealed as both ironclad and fragile, a paradox woven into the fabric of existence. Science renders this paradox into numbers, but life renders it into experience. You know entropy every time ice dissolves in water, every time your body ages, every time memory fades. You feel it in the irreversible cracking of eggs, the collapse of empires, the dying of stars. Entropy is not confined to laboratories. It is the pulse of mortality itself. To live is to watch order retreat second by second toward the final stillness of equilibrium. Even galaxies, those luminous engines of gravity and fusion, are slaves to entropy. Their stars burn hydrogen into heavier elements, radiating light into the cold abyss until fuel is gone and brilliance decays into darkness. Entropy is written in the death of suns as much as in the cooling of coffee, and yet entropy is not destruction for its own sake. It is transformation, a passage from concentrated energy into dispersed possibility. Every act of creation burns fuel. Every structure built must contend with decay. A forest grows only because the sun sacrifices order in nuclear fire, spilling photons into Earth's atmosphere. Life itself, with all its complexity and consciousness, exists because entropy allows energy to flow. The arrow of time is not merely decay, it is the pathway that makes existence dynamic rather than frozen. Without entropy, there would be no story at all. But here lies the mystery. Entropy is the arrow of time. We speak of past and future as if they were etched into the structure of reality, but the equations of physics, Newtonian, relativistic, quantum, are almost always indifferent to direction. They run equally well backward as forward. The trajectories of planets, the entanglement of particles, the rippling of fields, all are reversible in principle. Nothing in the deep laws of physics demands a preferred direction, and yet our world is drenched in irreversibility. Why? The answer is entropy. We know the past because it was more ordered. We expect the future because it will be less. A photograph does not fade into color from chaos, it fades into blankness, because blankness corresponds to more possible arrangements. We remember childhood because memory records order, not disorder. In this way, entropy is not only the arrow of time, it is the reason time feels like it exists at all. Without entropy's asymmetry, the distinction between yesterday and tomorrow would vanish. There would be no flow, only a static, eternal equation. To grasp this, imagine a film reel. If you watch a video of billiard balls colliding, you cannot always tell whether it runs forward or backward. The underlying physics is reversible. But if the film shows an egg falling and shattering, the direction becomes obvious. Why? Because entropy dictates irreversibility. The shattered egg embodies an astronomically greater number of microstates than the pristine shell, so the forward flow of disorder marks the arrow of time. Entropy gives reality its direction, the unmistakable sense that events march from order into chaos, never the reverse. Statistical mechanics makes this vivid. Consider molecules in a room. At any moment, there is a vanishingly small chance that all molecules cluster into one corner, leaving the rest of the room empty. But the chance is so low that it dwarfs imagination. The disorderly distribution of molecules is not mandated but inevitable by sheer probability. Time, as we perceive it, is nothing more than our witness of these probabilities unfolding. We call the forward march of entropy future, and the improbable reverse impossible. But at the level of mathematics, both directions are allowed. The difference lies only in likelihood. This recognition unsettles, for if time's arrow is not baked into the fundamental laws but arises from entropy, then time itself is an emergent phenomenon. It is not ultimate, it is contingent. That means the arrow we cling to, the sense of forwardness that defines birth, growth, decay, and death, is less a cosmic necessity and more a cosmic condition. And conditions can, in principle, be reversed. If entropy were to run backward, time itself might dissolve. The past would no longer stand behind us, and the future would no longer stretch ahead. Instead, both directions would collapse into symmetry, and the story of existence would evaporate. Textbooks present entropy with confidence. Disorder increases, systems evolve toward equilibrium. The arrow of time points forward. These are truths, as far as we ever observe. But in that very confidence lies the disquieting mystery. If entropy is probability, not prohibition, then why has the universe so consistently obeyed it? Why do we never see the improbable? Why, in a cosmos governed by reversible laws, does irreversibility reign? The philosopher inquires where the physicist hesitates. Perhaps our reality is not the full reality. Perhaps the arrow of time is a shadow, not a pillar. Perhaps entropy is not absolute law, but an echo of initial conditions, a consequence of the way the universe began. Cosmology gives weight to this suspicion. At the Big Bang, the universe was hot, dense, and improbably ordered. Gravity had not yet sculpted galaxies. Particles had not yet clumped into chaos. From that low entropy beginning, disorder had endless room to grow. Entropy is not destiny, it is inheritant. Our arrow of time is a relic of a strangely ordered birth, and if the universe had begun differently, we might not even perceive time's passage. Without the imbalance, there would be no history, no change, no before or after. In this light, the arrow of time is fragile, conditional, and perhaps local, not eternal truth. This realization deepens the mystery rather than solves it. Why did the universe begin in such an ordered state? Why was the initial entropy so low? What enforced this improbable condition at the origin of everything? No one knows. Physics answers many questions, but this one remains suspended. And until it is answered, entropy holds us hostage. We live in its direction, we age in its shadow, we die in its inevitability. Yet we cannot prove that this inevitability is ultimate. We cannot prove that the arrow cannot bend. So the unsettling question rises: if entropy defines the arrow of time, could reversing entropy undo time itself? What would it mean for memory, identity, and existence if the probabilities tilted in the opposite direction? Would we awaken into our past? Would we collapse into origins we no longer remember? Would the universe become a mirror, reflecting us backward into what once was? Or would everything, matter, mind, and meaning, dissolve into a timeless equilibrium where direction is meaningless? Entropy grounds us in physics, but it opens us into philosophy. It reassures with its consistency, while terrifying with its fragility. It defines the march of time, while whispering that time is not fundamental. And it closes this chapter of our inquiry with a haunting thought. The arrow that points us forward is not carved into stone, but painted onto the surface of probability. What happens when the paint fades or the surface cracks? What happens if entropy itself turns? Ancient dreams of eternal return, long before the language of thermodynamics, before entropy was etched into equations, humanity dreamt of time's reversal. Ancient myths whispered in temples and sung beside fires envisioned a universe that did not march relentlessly forward, but circled back upon itself. To our ancestors, Time was not a line ending in darkness. It was a wheel turning endlessly, returning always to the same horizon. What we now call physics, they called fate. What we name entropy, they called decay and renewal. And at the heart of their visions lay a haunting promise. Nothing is lost forever, for all things return. Consider the Hindu conception of the yugas, cosmic ages that rise and fall like breaths of the eternal. In this vision, time unfolds not in a straight march toward oblivion, but in vast cycles. A golden age of purity and harmony collapses into darker epochs of strife and decay, only for the wheel to turn once more, bringing light out of darkness. Creation is never final, destruction never absolute. The universe is reborn endlessly like a phoenix from its ashes. To live within such a vision is to see entropy not as doom but as rhythm, the pulse of existence itself. The Greeks too dreamed of recurrence. The Stoics spoke of ekpyrosis, the great cosmic conflagration. For them, the universe was destined to burn in a divine fire, only to rise again in the same form. Each life lived over, each event repeated with exact precision. What we call linear time, they imagined as eternal return. The cosmos itself was a phoenix, reborn from its own flame, carrying forward not novelty but repetition. Each soul, each star, each tragedy and triumph would unfold again, exactly as before, an infinite loop written in the script of fate. Nietzsche, in the 19th century, revived this vision with startling intensity. His doctrine of eternal recurrence was not presented as mere mythology, but as existential test. Live as though every choice, every moment, every joy and despair must repeat eternally. Imagine the weight of that thought. If time loops, then there is no final escape, no ultimate death, no end to suffering, but also no loss of beauty. Every instant is preserved because it will return. Eternity is not linear vastness but endless circling. In this sense, eternal recurrence is both terror and redemption, demanding that we affirm life even if it is condemned to repeat forever. What unites these myths and philosophies is not their detail, but their defiance of entropy's finality. Where modern science sees a universe running down, ancient cosmologies envisioned rebirth. Where physics speaks of heat death and fading stars, myths spoke of cycles that refused to die. To imagine recurrence is to resist the abyss, to insist that what is precious cannot vanish without return. It is perhaps the oldest rebellion against the arrow of time. Yet here lies the contrast. Modern physics describes entropy as probability, and time's arrow as consequence of disorder. Ancient thought described cycles as destiny, woven into divine order. One rests on statistics, the other on metaphysics, but is the difference absolute? Or might the myths echo truths not yet fully understood? Could the eternal return, dreamt by sages, be a metaphor for cosmic cycles glimpsed only now in equations and cosmology? In Hindu cosmology, the yugas stretch across incomprehensible spans of time, billions of years in a single cycle. Strikingly, modern science too now measures cosmic history in billions of years, discovering epochs of formation and collapse, of stars born and extinguished. The Stoics envisioned fire consuming and regenerating the cosmos. Today, physicists speak of big bangs and possible big crunches, universes expanding and perhaps contracting, annihilation giving birth to creation. Nietzsche demanded that we live as though time repeats eternally. Quantum mechanics whispers of probabilities playing out endlessly in multiverses, histories branching in infinite echo. Myth and physics, separated by centuries, sometimes converge in uncanny resonance. But perhaps these myths reveal less about the cosmos and more about us. Humans fear oblivion. We grieve the arrow of time because it leads toward decay, death, and disappearance. To imagine recurrence is to soothe that grief, to promise that What is lost returns, that memory is not erased but recycled. The longing for cycles may be the longing for immortality transposed onto the scale of the universe. Eternal return, then, could be projection, the refusal to accept finality. And yet, what if the refusal touches a truth? History shows that human intuition, wrapped in story and ritual, often gestures toward realities science later deciphers. Long before astronomy proved the Earth orbits the Sun, myths spoke of cosmic wheels and rotation. Long before genetics, cultures imagined blood as the carrier of ancestral memory. Could it be that the cyclical cosmologies of our ancestors are faint recollections of deep cosmic patterns, truths felt but not yet measured? Today, some physicists speculate about universes that cycle endlessly. In theories of the Big Bounce, cosmic expansion may one day reverse, collapsing into a singularity that explodes again, repeating without end. In eternal inflation, bubbles of universes constantly sprout, each birth echoing creation anew. In certain models of thermodynamics, time itself may be symmetric, with entropy increasing in one direction from a low entropy origin and in another direction from a mirrored origin, two arrows pointing away from a shared beginning. In such visions, eternal return is not myth but mathematic. But whether myth or physics, the theme persists, the dream of reversal, the refusal of linear finality. Cultures across continents imagine cycles not by coincidence, but because the mind recoils from endings. Eternal return transforms death into a pause, decay into a phase, entropy into rhythm. It says, what goes is not gone, it will rise again. And whether that is cosmic truth or human hope remains the great ambiguity. The arrow of time divides these visions. Physics insists on one-way disorder. Myth insists on recurrence. And we, caught between, ask, are myths echoes of deep cosmic truths, or are they mirrors of our fears and desires? Do we dream of cycles because they exist, or because we cannot endure the thought of absolute ending? The tension lingers like a chord unresolved. What is certain is this: the forbidden question that haunts physics today was already haunting humanity thousands of years ago. Long before entropy, people asked whether time could reverse. Long before equations, they imagined recurrence. We are not the first to rebel against inevitability. We are heirs to a lineage of longing that stretches back to the first storytellers. The ancient dreams of eternal return remind us that time is not just a scientific puzzle, but a human mystery, one that has never ceased to stir imagination. So as we stand at the threshold of modern science, gazing into the equations of thermodynamics and the paradoxes of entropy, we carry with us these ancient echoes. They remind us that to ask whether entropy might run backward is not only a technical question, it is a question of destiny, memory, and meaning. Myths gave one answer: yes, time reverses, for all things return. Physics hesitates, caught between probability and possibility, and between them lies our curiosity, our refusal to stop asking. Thus the bridge is built from ancient cycles to modern equations, from myth to science. The question persists, evolving in language but not in essence. If entropy is the arrow of time, then to dream of eternal return is to dream of its reversal. And perhaps, just perhaps, those dreams are more than illusions. Perhaps they are whispers of truths the universe has not yet revealed. The science of reversal. Could entropy decrease? The thought seems impossible. Entropy, once increased, does not retreat. Glass does not unshatter, ashes do not leap back into logs, suns do not relight their extinguished fires. Yet when we press the mathematics of thermodynamics, a strange possibility emerges. Entropy can, in principle, decrease, not by will or design, but by the same dice that roll the universe forward. This is not miracle, but probability, vanishingly small yet never zero. And if probability rules all things, then the arrow of time is not an unbreakable law, but a game of odds. Could the universe, however briefly, cheat its own direction? to answer, we must descend into statistical mechanics, where the second law of thermodynamics reveals its true nature. Here, entropy is not a divine command but a measure of likelihood. The famous physicist Ludwig Boltzmann gave us the formula S all bash and K log. W. Entropy is the logarithm of the number of microstates, the microscopic configurations of particles that correspond to a macrostate, the large-scale condition we actually see. The more ways disorder can manifest, the higher the entropy. A room full of evenly spread air molecules has an astronomically greater number of microstates than a room where every molecule clumps into a single corner. Both are possible. One is overwhelmingly probable. Entropy increases not because it must, but because disorder almost always wins. And yet, probability never forbids the improbable. Given enough time, molecules might gather spontaneously, reversing diffusion. Given enough time, a broken glass might reassemble, each shard colliding in just the right way. These are statistical fluctuations, temporary decreases in entropy. The second law allows them, it even predicts them. Their impossibility is practical, not absolute. They are so rare, so staggeringly unlikely, that we can live entire lifetimes without witnessing one. Yet in the cold language of probability, they are inevitable eventually. Here enters one of the strangest implications in all of physics, the idea of Boltzmann brain. If entropy is probability, then in an infinite universe, fluctuations will occasionally produce pockets of decreasing disorder. Among those fluctuations, it is more probable for random particles to assemble into a self-aware brain, complete with false memories, than for entire universes to form. In other words, the cosmos may generate conscious illusions more easily than it generates consistent reality. The haunting suggestion follows. Perhaps you, here and now, are a Boltzmann brain, a temporary fluctuation of entropy, convinced of a past that never happened. Perhaps memory itself is a trick of improbability. This speculation borders on nightmare, yet it is the logical consequence of taking statistical mechanics seriously across infinite spans of space and time. Entropy cannot be stopped, but it can be momentarily reversed. In fact, over eternity, it must be, which brings us to the paradox of recurrence. In the 19th century, Henri Poincaré uncovered a theorem that rattled the foundations of physics, the Poincaré recurrence. It states that any finite system left to evolve long enough must eventually return arbitrarily close to its initial state. Imagine a box of gas molecules endlessly bouncing. Though the system explores an almost limitless range of configurations, the mathematics demands that after inconceivably long durations, it will come back to a state nearly identical to its beginning. In other words, given infinite time, every arrangement repeats. Entropy may surge upward for aeons, but recurrence ensures that it will eventually swing back. Disorder becomes order again, not by miracle, but by necessity. The implications are staggering. If the universe is finite yet eternal, then every configuration must return. Every life, every moment, every star and planet will reappear, not once, but infinitely many times. History itself will rewind frame by frame like a cosmic film reel looped forever. The arrow of time, so firm in our perception, dissolves into cycle. Entropy increases, then decreases, then increases again, endlessly. The forbidden question, could entropy run backward, finds its answer here. Yes, it must, though only across spans so vast that imagination collapses under the weight of their enormity. But what does vast mean in this context? To picture it, consider that the recurrence time for even a simple system, like a few dozen particles in a box, is longer than the age of the universe by orders of magnitude, so extreme they defy language. For a system as complex as the cosmos, the recurrence time is so far beyond calculation that calling it long is an understatement. It is time measured not in billions of years, but in numbers so large they outstrip comprehension, more digits than atoms in the universe. And yet, probability insists. However unimaginable, recurrence remains inevitable if time stretches into infinity. Here lies the paradox. Locally, entropy feels absolute. We never witness its reversal, never see disorder collapse into order. Globally, Across eternity, entropy's dominion is not eternal. Given infinite time, the improbable is not just possible, it is guaranteed. Our universe could, after unfathomable spans, reconstruct its earliest state, the way a shuffled deck of cards eventually, with infinite shuffles, returns to perfect order. This vision transforms entropy from one-way arrow into oscillating rhythm, concealed only by the scale of time. Yet this raises profound question. If recurrence is inevitable, is the universe bound to repeat itself endlessly? Is existence condemned to eternal return, not as myth, but as mathematics? Does every moment we live, every word spoken, every breath taken recur infinite times, scattered across the eternity of recurrence? The thought converges eerily with Nietzsche's doctrine of eternal recurrence, except here the weight comes not from philosophy but from physics. Where ancient myths dreamed, mathematics insists. But not all. Physicists embrace this conclusion. For recurrence to apply, the universe must be finite in configuration space. What if it is not? What if the cosmos is infinite in extent, its states unbounded? Then recurrence dissolves, entropy climbs without loop, and time's arrow remain one way. Others argue that quantum mechanics complicates the story. Quantum states do not behave like classical systems of gas molecules. They inhabit vast Hilbert spaces where recurrence is more nuanced. In this quantum light, the certainty of eternal return fades into debate. The paradox remains unresolved. Even so, the possibility cannot be dismissed. If the cosmos is finite and eternal, then every fluctuation, however improbable, must occur. This includes not only reversals of entropy, but entire histories replaying themselves. Somewhere in the endless sweep of time, you are born again, live again, ask again whether entropy can reverse. Not once, but endlessly. The universe becomes a mirror house, every corridor reflecting the same figures in endless repetition. The uniqueness of existence dissolves, all that remains is recurrence. And yet, recurrence unsettles rather than comforts. For if everything repeats, then novelty is illusion. If time cycles, then progress is a mirage. Entropy's tyranny gives life direction, but recurrence erases that direction, trapping us in eternal loops. Which is more terrifying, the heat death of the universe, where all fades into stillness, or the infinite rerun of every joy and sorrow played back without end? The science of reversal confronts us with both nightmares at once, entropy increasing without mercy and entropy decreasing without escape. In the end, the paradox of entropy reveals its dual face. Locally, within human scales, disorder is irreversible. No life rewinds, no glass restores. Globally, across eternity, reversal is certain. The arrow of time is both iron and illusion, both destiny and cycle. And between these extremes we live, caught in the narrow span where entropy only increases, where time only moves forward, where memory has meaning. Our world feels absolute, but in the mathematics of infinity, it is provisional. This is the strange power of science. It dismantles the obvious and reveals the impossible lurking underneath. To ask whether entropy can decrease is to step into a universe where probability rules over law, where brains can flicker into existence out of chaos, where whole histories repeat not as dream, but as theorem. It is to accept that the arrow of time, which feels so steady beneath our feet, may be only a local phenomenon, destined to bend, destined to loop, destined to reverse. The cosmic film reel may yet rewind. And if it does, what will become of us? Are we characters trapped in an eternal playback, forever condemned to repeat? Or are we fleeting fluctuations, ephemeral illusions in an infinite sea of probability? The science of reversal leaves us with no certainty, only haunting possibility. Entropy decreases rarely but inevitably. The universe may repeat endlessly or dissolve into silence. And we, suspended between probability and inevitability, must face the forbidden conclusion. The arrow of time is not absolute. It is a gamble, and the dice are still rolling. Entropy at the edge of the universe. Close your eyes and imagine the farthest horizon of time. Not tomorrow, not a billion years from now, but the final epoch, the last chapter written in the cosmic book. Galaxies have drifted apart until their light no longer bridges the void. Stars have burned through their fuel, one by one extinguishing their fires. Black holes, once the great devourers of the cosmos, evaporate into ghostly radiation, leaving behind only silence. What remains is neither life nor death, but a perfect equilibrium, a universe of maximum entropy where no gradient exists, no difference remains, and no change is possible. It is the stillness after all motion, the silence after all song. This is the heat death of the universe, the ultimate consequence of entropy's dominion. The vision is chilling. Heat death is not fire, but emptiness, not a blaze of destruction, but a leveling of everything into sameness. Entropy, in this final form, means the end of time as experience. Without differences in temperature or structure, nothing happens. A cosmos in equilibrium is a cosmos without story. Every atom drifts alone in endless darkness, indistinguishable from its neighbor. The universe, once ablaze with galaxies, collapses into monotony. The arrow of time ends not in reversal, but in stasis. This is one possible fate of all things, and it emerges naturally from the second law. If entropy tends always to increase, then eventually it must reach its maximum. Once there, no process remains to push it further. No heat flows, no stars burn, no complexity survives. It is the end of history. In this bleak picture, entropy is not only the arrow of time, it is the executioner of meaning itself. And yet, not all is settled. For while heat death remains the standard cosmological forecast, alternative visions challenge its inevitability. In the depths of black holes and the fabric of space-time itself, entropy may behave in ways that defy our intuition. Perhaps the edge of the universe is not silence, but transformation. Perhaps the arrow of time does not end, but turn. Black holes provide the most dramatic confrontation with entropy. These objects are the very embodiment of disorder, regions where matter collapses into singularity and information appears to vanish. According to classical physics, nothing escapes. Their event horizons, not even light. Yet in the 1970s, Stephen Hawking revealed that black holes radiate, gradually evaporating as quantum effects near the horizon create pairs of particles, one swallowed, the other escaping. This Hawking radiation means that black holes, the most ordered prisons of matter, are themselves engines of entropy. Over unimaginable spans, they leak their energy back into the cosmos until nothing remains. But this raises the profound puzzle of information. If matter and its quantum states are lost within black holes, then entropy increases beyond retrieval, the ultimate act of disorder. Yet many physicists argue that information cannot be destroyed. If so, then even in the heart of entropy's abyss, some hidden law preserves order. The paradox of black holes suggests that the second law, while relentless, may not be final. It hints at quantum processes capable of weaving back what appeared undone, of storing memory even in the face of cosmic erasure. Beyond black holes lies an even greater speculation, the fate of the universe itself. The cosmos today is expanding, driven faster and faster by what we call dark energy. If this continues unchecked, galaxies will drift infinitely apart, stars will burn out, and entropy will maximize in eternal heat, death. But what if expansion reverses? What if the universe, after ages of outward flight, begins to collapse inward under its own gravity? In this scenario, the Big Crunch, entropy might not end in stasis but transform in collapse, matter and energy. could compress into a singular point, erasing distinctions, then explode outward again in a new Big Bang. The universe would not end but bounce. Entropy, instead of marching to silence, would reset into rhythm, beginning the cycle anew. This vision echoes ancient myths of eternal return, but here, physics provides the mechanism: quantum gravity. At scales where relativity and quantum mechanics collide, space-time itself may resist singularity, producing a bounce rather than an end. In loop quantum cosmology, for instance, space is quantized into tiny units, preventing infinite collapse. Instead, the universe contracts to a finite minimum and then rebounds, igniting creation again. In such models, entropy does not annihilate, but recycles. The arrow of time bends, if not backward, then into cycle. Cinematic imagery almost writes itself, the universe drifting into frozen silence, then collapsing inward, folding galaxies into a point of unbearable density, and then ignition, a flash. Brighter than imagination, an eruption of order from stillness, entropy flowing backward into possibility, time restarting its flow. In such a cosmos, heat death is not finality but prelude, the breath between inhalation and exhalation. But skeptics abound. Even in cyclic cosmologies, entropy remains a thorn. If each cycle inherits the entropy of the last, then disorder accumulates. With every bounce, the universe becomes less structured, more degraded, until eventually cycles collapse under the weight of entropy. To reset fully, something more radical must occur, a mechanism not only to rebound but to erase. Whether quantum gravity can achieve this remains unknown. Some theorists suggest entropy itself might reverse across the bounce, flipping the arrow of time. In that case, the universe would not merely restart, it would run in the opposite direction. The future of one cycle would be the past of the next, stitched seamlessly across the boundary. Our end might be another beginning, viewed from the other side of time. Such speculations blur the line between science and philosophy. Heat death presents a universe that ends in silence, eternal and indifferent. Bounce theories propose a cosmos that regenerates, rhythmical and endless. Which is true? Neither has proof. Observations show expansion accelerating, consistent with eternal heat death. But our understanding of dark energy remains incomplete and quantum gravity remains undiscovered. The edge of the universe is shrouded not in certainty but in mystery. Yet even uncertainty has meaning, for it reveals that entropy, though relentless, is not simple. At cosmic scales, disorder is not only destruction, but transformation. Stars die so that heavier elements may form. Black holes evaporate, perhaps preserving information. Heat death looms, but bounces beckon. The arrow of time may point forward, yet at the edge of the universe it may curve, loop, or dissolve. The second law is not a wall, but a horizon, one we approach with awe, knowing the unknown lies beyond. What is more terrifying, an eternity of stillness or an eternity of recurrence? The heat death strips the cosmos of meaning by freezing it into sameness. Bounce cosmologies strip meaning by denying finality. History repeats, novelty dissolves. Nothing is truly new. Entropy confronts us with two abysses: silence without return or return without escape. Both stretch imagination to its limits. Both challenge our place in the cosmic order. Are we fleeting sparks in a dying flame, or characters in a story told infinitely many times? At the edge of the universe, entropy ceases to be abstract. It becomes destiny. Whether that destiny is silence or cycle, stasis or rebirth, remain unknown. But one truth shines through. Entropy is not simply the decay of order. It is the stage upon which existence plays. It frames the beginning and the end, the birth of stars and their collapse, the flow of time and its possible reversal. To understand entropy is to glimpse not only the arrow of time, but the fate of everything. So we return to the forbidden question, now sharpened to its cosmic point. If entropy defines existence, what happens when it reaches its maximum? Does the universe collapse into eternal stillness? Or does it ignite again, reversing its course, bending time itself. At the edge of the universe, the answers blur. Science offers models, myths echo through them, and philosophy whispers in their gaps. What remains is awe before a cosmos vast enough to die, vast enough to be reborn, vast enough to hold both silence and flame. And perhaps that awe is the true inheritance entropy leaves us. For whether the arrow of time ends in equilibrium or reversal, the journey through its mysteries teaches us what it means to exist at all. To live in a universe governed by entropy is to live in wonder at beginnings, endings, and the possibility that they may be the same. Quantum reversals, where disorder becomes illusion. At the smallest scales of reality, time does not flow. It hovers, it mirrors itself. It obeys equations that make no distinction between past and future. This is the strangeness of quantum mechanics. Beneath the world of irreversible decay and relentless entropy, the laws of nature appear symmetrical, reversible, indifferent to direction. If you could watch an electron scattering or a particle tunneling, you would find no sign of an arrow pointing forward. The mathematics works just as perfectly in reverse. Yet when these microscopic symmetries accumulate into the macroscopic world, into glasses breaking, stars burning, lives aging, irreversibility dominate. Why? How can the foundations of the universe be timeless while our lived reality is chained to entropy's march? The puzzle begins with Schrödinger's equation, the core of quantum theory. This equation governs how quantum states evolve, and it is perfectly time reversible. If you were to film the evolution of a wave function and then play the film backward, the equation would remain valid. Nothing in quantum dynamics cares about direction. The same is true in quantum field theory. Particle interactions, scattering, events entanglement, all unfold according to laws symmetric in time. The cosmos at its most fundamental level does not know past or future. It only knows possibilities. And yet, when those possibilities collapse into measurement, we encounter irreversibility. The act of observation appears to break symmetry. A wave function that once spread across many options chooses a single outcome, and in doing so creates an arrow. The quantum world, so fluid and reversible, crystallizes into an irreversible moment. Was the cat alive or dead? Before observation, both. After observation, only one. This collapse has no reverse button. Once the wave function reduces, the other possibilities vanish. Entropy seeps in at the boundary between quantum possibility and classical certainty. Here lies the paradox. On one level, quantum laws are reversible. On another, our world built from them is not. Why should the arrow of time emerge from timeless foundations? Some physicists argue that the arrow is not fundamental but emergent, a byproduct of scale. Microscopic reversibility does not vanish. It is merely drowned by the overwhelming probabilities of macroscopic systems, countless particles, each obeying symmetric laws create ensembles whose entropy almost always increases. In this view, the arrow of time is an illusion born of statistics, not an inherent feature of the cosmos. Cinematic imagery sharpens this idea. Picture a single atom dancing in quantum superposition. Play the film backward and nothing looks strange. But now, zoom out to a human body. Trillions of atoms woven into memory, metabolism, thought. Here, the backward film looks absurd. A meal undigested, words unspoken, life unwound. The difference is scale. Entropy dominates where numbers overwhelm. What is reversible for the atom is irreversible for the person. Disorder, in this sense, is not fundamental but emergent. It is the shadow cast when countless symmetries overlap. Still, not everyone agrees. The measurement problem haunts quantum theory. If quantum laws are reversible, why does collapse appear irreversible? Is collapse real, or is it illusion? Some interpretations of quantum mechanics, such as the many worlds interpretation, deny collapse altogether. In this picture, every quantum possibility persists, branching into parallel realities. Entropy, then, is not the destruction of alternatives, but their proliferation. Disorder may not be growth of chaos, but expansion of possibility. What feels like irreversibility in our branch is symmetry across the multiverse. Other interpretation invoke decoherence, the entanglement of quantum systems with their environment. A quantum state, once interacting with countless surroundings, loses coherence, and probabilities become certainty. This process, though, is still governed by reversible laws. Decoherence explains why we do not witness macroscopic superpositions, but it does not abolish time symmetry at the core. Even here, the arrow of time emerges not from fundamental law, but from the way systems entangle, the way observers are embedded within their environment. Irreversibility, once again, looks like illusion. The implications run deep. If entropy's arrow is emergent, then time itself may be a construct, a feature of our perspective rather than of the universe. Quantum mechanics whispers of a reality where past and future are not distinct, where the film of existence can run either direction. We perceive direction because entropy overwhelms us, because the scale of our lives amplifies probabilities into apparent certainties, but beneath that appearance lies symmetry, reversible and timeless. Disorder, then, may not be ultimate. It may be a mirage. This thought is almost unbearable. To live is to feel time as necessity. We are born, we age, we die. Entropy defines this flow, yet quantum theory suggests that beneath our grief lies a symmetry immune to decay. What we call death may be only irreversibility at our scale, while at deeper levels, reality does not acknowledge endings at all. The arrow of time, so merciless in daily life, dissolves in quantum equation. Is it possible, then, that disorder is only a story we tell ourselves, a story useful for survival, but not for truth? And if entropy is illusion, what of memory? We remember the past, not the future, because information is recorded in increasing disorder. But if the quantum world is reversible, then perhaps memory too is conditional. Perhaps the past exists, not because it happened, but because entropy permits it to appear coherent. The future may be no less real. It simply hides behind probabilities we have not yet observed. In this light, the arrow of time becomes a boundary of perspective, not of reality. Time does not flow, we do. Such reflections return us to the forbidden question. If entropy is emergent, then reversing it may not require breaking laws but shifting perspective. Perhaps at quantum scales, reversals occur constantly, unnoticed by our macroscopic minds. Entropy increases for us, but not for reality itself. Disorder, in this view, is illusion. The world is timeless, and the arrow exists only inside the human frame. But illusions can still be powerful, for even if entropy's arrow is emergent, it shapes the universe we experience. Stars burn, lives
and civilizations crumble. The symmetry beneath does not save us from irreversibility at our scale. The tension is inescapable. Time symmetric below, time asymmetric above.
Physics insists both are true, yet our existence lives only in the gap between them. The mystery lingers. Why does symmetry give rise to asymmetry? Why does the timeless give rise to time? Some argue the answer lies in cosmology, in the low entropy of the early universe. Others suggest it lies in consciousness, in the peculiar way observers carve probabilities into narratives. Still others leave it unresolved, content to marvel at the paradox. Disorder may be illusion, or it may be emergent fact. Either way, it refuses to vanish. At the frontier of quantum theory, entropy becomes a mirror. Look deeply, and the arrow of time fades. Look away, and it reasserts itself with merciless clarity. The truth may be that both visions are real. Beneath symmetry, above irreversibility, entropy becomes both law and illusion, both shadow and substance. And in that paradox lies the essence of quantum reversals. So we are left with a haunting possibility. Entropy is not fundamental. The disorder we fear, the arrow we obey, may be the artifact of perspective, not the decree of reality. At its core, the universe may be timeless, reversible, eternal. And if so, then the forbidden question deepens. If disorder is illusion, what else in our experience dissolves under scrutiny? Is death itself illusion? Is time? The quantum world does not answer. It only whispers, past and future are the same, and the arrow is drawn in sand. The brain against time, every heartbeat, every recollection, every act of imagination rests on an invisible current, the flow of time. We do not simply exist in time. We inhabit it, stitched into a forward movement we cannot escape. Memory reaches backward, anticipation stretches forward, and identity itself is carved by this asymmetric divide. Without entropy's arrow, consciousness as we know it could not exist. To be human is to be a creature of irreversibility. But what if the arrow turned? What if the brain awoke in reversed time? Would we still recognize ourselves, or would memory itself collapse into absurdity? Neuroscience offers one answer. The brain encodes experience by writing patterns into networks of neurons. Memories form when synapses strengthen, when traces of chemical and electrical activity carve themselves into living tissue. But this process is inherently directional. Information is recorded by entropy's increase. Energy flows, molecules shift, patterns stabilize. Each memory leaves behind a scar of irreversibility. The past can be remembered because its trace persists in physical order, but the future cannot be recalled because it has left no imprint. Our sense of temporal direction is not an illusion, imposed after the fact histo. It is built into the machinery of cognition. Causality follows the same path. We assume that causes precede effects, that pushing a glass makes it fall, not the other way around. Yet in physics, the equations allow both orders. Why then does the brain insist on one? Because causal inference depends on entropy. The brain interprets sequences by detecting the asymmetry of disorder. Milk spreads through coffee, not coffee leaping back into milk. We learn cause from effect because the universe around us enforces irreversibility. Our sense of logic, our capacity to reason, arises from entropy's dominance. Remove it, and reason itself frays. But imagine the impossible, a consciousness adrift in reversed time. Stars grow brighter, not dimmer. Ashes leap into flame. People grow younger, their memories draining away as their bodies unage. What would it mean to live in such a world? Would we remember the future, replaying what has yet to happen? Or would memory itself lose meaning, dissolving in the absence of asymmetry? Philosophers of mind struggle with this question. If the brain truly operated in reversed time, then the very act of remembering would invert. What we call anticipation might become recollection. The future would feel known, the past forgotten. A kiss would be experienced as the echo of lips parting, not meeting. Death would be the birth we remember, birth the death we anticipate. In such a reality, identity could not cohere. What we call a self is the thread of continuity woven by memory. Break that thread, invert its weaving, and the fabric of personhood may unravel. And yet some argue that consciousness is not bound to entropy so rigidly. Perhaps awareness is less about direction and more about relation, the comparison
of states, the experience of different.
In this view, a reversed brain might still construct a narrative, though alien to us. It would remember what we call the future and forget what we call the past, yet still feel oriented. Time's arrow would flip, but the sense of flow might remain anchored not in reality but in perception itself. Could such a being exist, certain that its way of remembering is natural, blind to the fact that its arrow contradicts ours? The thought is eerie because it exposes the fragility of our
confidence.
We believe we move forward, but our conviction is built entirely on entropy's increase. If disorder were to reverse, would we even notice? Or would our brains simply rewrite the script, insisting always that memory points backward and anticipation forward, no matter which way the current flows? Perhaps consciousness is not the witness of time, but the prisoner of entropy. Whatever direction entropy runs, the brain will call it forward. Neuroscience deepens the mystery when it examines how the brain constructs the present. Studies show that perception lags reality by fractions of a second, stitching together sensory input into a seamless narrative. Our awareness of now is already a reconstruction, a guesswork built on fragment. Memory and anticipation intertwine. We predict what comes next and then fold those predictions back into recollection. The brain is not a camera recording reality, it is an editor, stitching disorder into coherent. Entropy provides the raw asymmetry, but consciousness provides the story. So what happens if the raw material changes direction? Would the editor still weave coherence, or would the story unravel into nonsense? Some neuroscientists suggest the latter. Without entropy's flow, information cannot be stored. Without storage, memory cannot exist. Without memory, selfhood collapses. A universe of reversed time may be conceivable to physics, but to consciousness, it may be uninhabitable. Existence without entropy's arrow may not merely be strange, it may be impossible for minds like ours. And yet the paradox persists. For if physics is time-symmetric, then somewhere in the equations lies the possibility of reversed experience. Perhaps other kinds of awareness could thrive in such conditions, minds not built on memory but on anticipation, beings for whom what we call the future is as tangible as our past. We cannot imagine them fully, but they remind us that consciousness is not universal law. It is adaptation. It reflects the environment in which it evolved. An environment defined by entropy's increase, change the flow, and consciousness itself may change. This realization draws us back to the existential. What is memory if not entropy carved into matter? What is identity if not the thread of irreversibility binding experiences together? To live against time is not only impossible, it is to ask what it means to be at all. The brain does not merely ride the arrow of entropy, it is built from it. Strip it away, and we may strip away not just memory, but meaning. And yet there is wonder here too, for in recognizing our dependence on entropy, we glimpse how fragile and miraculous consciousness truly is. We are not timeless souls drifting above physics. We are patterns of order, fragile eddies in the river of disorder. Our ability to remember, to imagine, to love, to hope, all arise because entropy flows in one direction. We are the children of irreversibility, the offspring of the arrow of time. And if that arrow were ever to falter, so too would the story of what it means to be human. Still, the forbidden question lingers. If entropy could reverse, would consciousness find a way to follow? Would the brain adapt, constructing a narrative in the opposite direction, convinced as ever that its way is forward? Or would the very possibility of awareness collapse into incoherence, leaving only silence? The answer remains hidden, suspended between neuroscience and philosophy, between what we know and what we cannot yet conceive. Perhaps the truth is that our experience of time is not truth at all, but interpretation. The brain, facing a universe of disorder, tells itself a story of flow, stitching memory and anticipation into a line. Whether entropy increases or decreases, the brain may always insist it moves forward. And if so, then consciousness is not the master of time, but its servant, forever bound to entropy's direction, whatever that may be. Reversal as salvation or doom? What if the arrow of time suddenly faltered? What if entropy, that relentless tide of disorder, didn't simply slow but turned? Would the universe awaken to resurrection, stars flaring back into brilliance, civilizations rising from ruins, every life replayed in luminous reversal? Or would this rebirth be no salvation at all, but annihilation of freedom, identity, and meaning as existence collapsed backward into predetermined order? Entropy reversed is a double-edged prophecy. It promises both redemption and terror, both paradise and prison. Imagine first the utopian dream. The dead awaken not as ghosts but as bodies undecaying, wounds unforming, breaths unleaving lungs. Cemeteries transform into maternity wards in reverse. The old become young, memory drains into innocent, and families reunite not by chance, but by certainty. Lost civilizations rise from dust, pyramids unerode, languages unforget, entire epoch of history unfurl backward, each act of destruction rewritten as creation. Bombs undetonate, wars unfight, empires reconstruct themselves. Even the stars join the resurrection. Supernovae implode into stability. Black holes disgorge their contents. The cosmos itself glows brighter instead of dimmer. In this vision, entropy's reversal is salvation. Death itself is undone. Every grief is healed by inevitability. What was lost returns, not once, but continuously, as time unravels itself toward improbable perfection. The nightmare of heat death, silence, darkness, stillness, transforms into the promise of cosmic youth regained. The dream is intoxicating, a universe where nothing is ever truly lost, where every spark returns to flame. But utopia dissolves when we look closer. If entropy runs backward, then every moment of resurrection is also an erasure. To rise from death is to lose the life that was lived. To grow young is to forget, not remember. To reunite with loved ones is also to lose them again, not to chance, but to certainty. For in reversed time, free will evaporates. Every step is determined. Every gesture mirrored, every event preordained. You do not relive your life relives itself through you, perfectly scripted, without deviation. Choice becomes illusion, novelty impossible, salvation curdles into imprisonment. Here lies the paradox. Reversal is resurrection and annihilation at once. To live again means to lose agency. To be reborn means to be erased. A universe of reversed entropy is not a second chance but a deterministic rerun. It is not freedom, but fate. We dream of endless rebirth, but what we receive is eternal. Repetition, a loop wound tighter than any myth of eternal return. Consider identity in such a cosmos. We know ourselves by memory, by the accumulation of choices, experiences, and scars. But in reverse, memory dissolves into anticipation of what we already know must occur. The self becomes less a subject than a puppet, pulled backward through a script written in stone. If time reverses, then the idea of individuality collapses. The you who believes you act is simply the byproduct of events unfolding in reverse inevitability. Identity becomes ghost, hollowed of freedom. Philosophy offers no easy escape. The ancient Stoics imagined cycles of fire and rebirth as divine order, demanding acceptance of fate. Nietzsche's doctrine of eternal recurrence challenged us to embrace even the repetition of suffering as affirmation of life. But entropy's reversal offers something darker, not affirmation, but inevitability without escape. Eternal return at least preserves the illusion of living forward, of choosing
again what has already been chosen.
Reversal strips even that comfort, forcing us to watch our lives unspool in retreat, every act of love undone, every triumph unachieved, every breath withdrawn. Is this salvation? Or is it doom? The answer depends on what we value. If resurrection is the highest good, then reversal is divine. If freedom and memory are essential, then reversal is annihilation. To awaken in a reversed cosmos is to confront a terrible question. Is it better to live without choice or to die with it? The contrast between utopia and nightmare grows sharper when we extend the thought to civilizations. Imagine humanity restored. Cities uncrumbled, knowledge unlost, forests regreened, history itself resurrect. Yet with each reversal, innovation evaporates. The printing press uninvents itself, vaccines dissolve, electricity undiscovered, rockets retreat into the ground. The story of human progress becomes regression, not by accident, but by cosmic law. Civilization's ascent unravels into primal beginnings, and then beyond civilization, life itself unevolves, species retreat into oceans, complexity simplifies, molecules unbind, atoms scatter. The dream of rebirth becomes the nightmare of unbecoming. On the cosmic scale, the paradox
intensified.
Stars that reignite do so not to blaze anew, but to retrace their prior states. Supernovae that implode back into stability are not acts of creation, but rewinds of destruction. Galaxies that cluster together again do so because they must, not because anything new arises. The universe does not evolve in reversed entropy, it regresses. The future collapses into the past, and the past into origin. The Big Bang itself reconstitutes not as mystery, but as destiny. Creation is not a possibility, it is the end point of annihilation. This vision chills because it strips meaning from existence. The arrow of time, harsh though it is, grants us freedom. It gives us direction, the capacity to choose, the chance to create. Entropy ensures irreversibility, but within that irreversibility lies novelty, spontaneity, surprise. If entropy runs backward, surprise disappears. The universe becomes a film reel, unspooling in reverse, every frame inevitable, every outcome known. What appears as resurrection is, in truth, the erasure of all possibility. And yet, there remains a seductive whisper. Perhaps reversal is not simply doom. Perhaps it is salvation in disguise. For what if freedom itself is illusion? What if memory and identity are always constructed stories, shadows of entropy's arrow? If so, then reversal does not destroy what we are. It merely rewrites the script. We may feel anticipation instead of memory, but to the mind immersed in reversed time, that experience would feel as natural, as free as ours does now. From within, doom may taste like salvation. The tension is inescapable. Reversal is both resurrection and erasure, both paradise and prison. It exposes the fragile threads that hold meaning together: memory, choice, identity, novelty. Without them, life may continue, but existence as we know it collapses. The utopian dream of endless rebirth dissolves into the nightmare of entropic inevitability. Yet the nightmare, viewed from within, might feel no different from our present lives. Perhaps what we call freedom is always the mask entropy allows us to wear. So we return to the forbidden question with sharpened urgency. If entropy could reverse, would we welcome it as salvation, or dread it as doom? Would the resurrection of all things redeem the loss of freedom, or would the erasure of freedom render resurrection meaningless? The cosmos itself remains silent. Physics only tells us that reversal is possible in principle, improbable in practice, inevitable in infinity. Philosophy tells us that meaning trembles on the edge between desire and fear, and we, suspended between these voices, must face the paradox. To dream of reversal is to long for what we have lost. To fear reversal is to protect what we have now. Salvation and doom are mirrors of the same event, reflections of entropy's forbidden retreat. Which one we see depends not on physics, but on what we believe life is for. At the edge of this paradox, awe lingers. For in contemplating reversal, we confront not only the fate of stars and galaxies, but the fate of meaning itself. Entropy defines existence by moving forward. If it moves backward, existence remains, but meaning dissolves. Salvation and doom, rebirth and annihilation are not opposites here. They are the same. The reversal of entropy is not an answer, it is a question posed to us, demanding we declare what we value most: freedom, novelty, identity, or permanence, resurrection, return. Perhaps then the true terror is not that entropy may reverse, but that if it does, we will never know the difference. We will believe we are free even as we retreat into inevitability. We will call resurrection salvation, blind to the fact that we are being erased. The dream of reversal may already be unfolding, and our certainty that time moves forward may be the illusion. Salvation and doom may be indistinguishable, two faces of the same cosmic mirror, entropy and the simulation. Hypothesis: imagine the universe as a program running on some incomprehensible machine. Stars flare because lines of code instruct them to. Electrons orbit not by necessity but by calculation. Time itself is not a river but a sequence of updates, frames processed one after the other. In this vision, reality is not matter at all, but information. And at the heart of its architecture lies a single, enigmatic rule: entropy must increase. But if the universe is code, then entropy is not an absolute law. It is a design choice. And what can be chosen can be rewritten. The simulation hypothesis has grown from science fiction into serious philosophical speculation. If advanced civilizations can run simulations indistinguishable from reality, then statistically we may already be inside one. In that case, the laws we call natural may not be laws at all, but programmed constraints, rules that maintain coherence in the system. Entropy, then, could be less a cosmic inevitability and more a parameter in the operating system of the universe. Consider how digital simulations of physics already work. In video games, particles scatter, heat diffuses, structures collapse, all according to coded rule. To the player, these events appear natural, governed by the same inevitability we associate with physics. Yet behind the curtain, every law is a line of code that could be modified at will. Change one variable and the arrow of time could bend. The rules of thermodynamics could reverse. To beings inside such a simulation, the difference would be undetectable. What feels like law is only stability maintained by code. If entropy is code, then its arrow may be less fundamental than we believe. It may be an emergent function designed to create the illusion of direction. Why would a programmer install such a rule? Perhaps because increasing entropy creates narrative. Without disorder, no story unfolds, no evolution occurs, no consciousness arises. Entropy fuels novelty, producing the complexity that gives rise to life and mind. Without it, the simulation would stagnate, a sterile perfection without history. By coding in entropy, the architects of the program ensure dynamism, conflict, growth, and decay. In short, a universe with meaning. But if entropy is written into the system, could it be rewritten? Could reversal of entropy be less a miracle of physics than a system reset, a reloading of the program? Imagine reaching the edge of cosmic time, where heat death threatens eternal stillness. In a natural universe, this is the end. In a simulated one, it may be nothing more than a shutdown, a reboot, a restoration to an earlier save. Entropy's reversal might not be a property of nature at all, but a function called by the program to refresh the system. This vision is as exhilarating as it is unsettling. For if entropy is code, then we are not merely passengers on time's arrow. We are data executing scripts. Memory is storage. Identity is process. The arrow of time is not a law, but an instruction set. And if the instruction changes, so too does everything we believe ourselves to be. Critics argue that this is speculation without evidence. But entropy itself provides the provocation. Why should time flow only one way when the fundamental equations of physics are reversible? Why should the universe begin in such low entropy, a condition so improbable it seems chosen? The asymmetry of entropy may not be natural accident, but artificial construct. The arrow of time in this light could be the signature of programming. It is not proof of simulation, but it is a clue, a suspicious anomaly in the structure of reality. Consider
Another parallel.
in computing, randomness is often simulated through algorithms that mimic chance. Entropy, in a physical sense, measures disorder and probability. In a simulated universe, what we call entropy could be nothing more than pseudo-randomness generated by code. To us, it feels absolute. To the system outside, it is a function running on repeat. If so, then entropy's apparent inevitability is nothing more than the reliability of software. And like all software, it can crash, reset, or be rewritten. The thought is dizzying, entropy as an illusion imposed by code. If that is true, then reversal becomes not only possible, but trivial. It would take no miracle of physics, only a change in the system's settings. The collapse of disorder into order would be nothing more than a patch, an update, a rollback to an earlier version of reality. From our perspective, it would be the most staggering event imaginable. From the perspective of the programmer, it would be as simple as typing a command. This idea casts new light on ancient myths of cycles and return. Perhaps the dream of eternal recurrence of cosmic rebirth is less prophecy and more intuition of the system's architecture. Perhaps civilizations in earlier cycles glimpsed the reset, encoding it into religion and philosophy. The yugas, the Stoic conflagration, the visions of Nietzsche. Could these be cultural memories of previous runs of the program? Entropy increases, then reverses, not because of cosmic law, but because the simulation demands maintenance. Yet this thought also breeds dread. If entropy is code, then our freedom may be illusory. We are not agents, but avatars. Our choices are calculations, our identities, threads of data. Entropy's arrow gives us the illusion of progress, but behind the screen, it is only cycles of execution. And when entropy reverses, we do not resurrect, we reset. What we call salvation may be nothing more than deletion and reload. Memory collapses, identity dissolves, and the program starts again. Reversal is not rebirth, but restart. This raises an even darker question. What if the purpose of the simulation is entropy itself? What if the architects, whether alien, machine, or unknowable mind, designed reality to watch disorder unfold? Each reversal may not be a mercy but an experiment. The universe runs forward until it decays, then it rewinds, then it runs again. We live not for our own sake, but as data in someone else's experiment. Entropy is not our fate, it is our function. And yet, even within this unsettling frame, war persists. For whether entropy is law or code, whether we are free or scripted, the experience of time remains. We love, we suffer, we imagine, we ask questions. The simulation, if it exists, does not diminish the reality of our experience. It only reframes it. Entropy may be the operating system, but meaning still arises within it. Even if reversal is a reset, even if memory is illusion, the fact that we are here, asking, remains miraculous. Still, the forbidden question echoes. Could entropy's arrow itself be the proof that we are simulated? Could its strange asymmetry, its improbable beginning, its looming reversal, all signal that we are not in a natural cosmos, but in a programmed one? If so, then the ultimate fate of the universe may not be heat death or rebirth, but update. The cosmos may not end in silence or fire, but in a flicker, the screen going black, the system rebooting, reality reloading. And when it does, would we know? Or would we, like every program reset, awaken as if for the first time, blind to the cycles that came before? The paradox of the observer. The arrow of time feels absolute, but it is inseparable from the beings who perceive it. Entropy defines history, memory, and expectation, yet observers themselves are creatures of entropy. We measure the universe, but we are not independent of it. Our perceptions, our memories, our very sense of identity are etched into matter by irreversible processes. To ask whether entropy can reverse is also to ask what happens to the observer when it does. Can time truly run backward if the minds that register its flow are themselves bound to disorder? Physics strives to separate observer from system. Equations describe particles, fields, and energy as if detached from perception. Entropy in statistical mechanics is defined objectively, the measure of possible microstates corresponding to a macrostate. It seems impersonal, cold, absolute. But in practice, entropy is always relative to what an observer can distinguish. The molecules in a glass of water may occupy countless configurations, but we see only ice or liquid. We label the system by coarse categories, ignoring the impossible detail of every microstate. Entropy rises not because nature prefers disorder, but because our perspective cannot track the precise order that remains hidden. In this sense, entropy is not simply out there in the universe. It emerges in part from the limits of observation. This raises a disturbing thought. If entropy depends on how observers coarse-grain reality, then the arrow of time may also depend on perspective. Perhaps disorder increases only because we are built to measure it that way. Perhaps another kind of observer with different faculties might perceive time flowing in the opposite direction. In that case, reversal of entropy might not require the universe itself to change, only the vantage point of consciousness. Quantum mechanics sharpens this paradox. At the microscopic level, the equations are time-symmetric. The wave function evolves reversibly, caring nothing for past or future. Irreversibility appears only when observation enters. The act of measurement collapses the possibilities into a single outcome. But who is the measurer? An observer. Consciousness, entangled with the system, creates the asymmetry. Some interpretations of quantum theory suggest that without observers, there is no arrow at all. Time becomes directionless possibility, awaiting perception to split it into past and future. If so, then entropy's increase is not fundamental. It is the reflection of observation itself. Imagine then a reversal not of the cosmos, but of the mind. Suppose consciousness itself were inverted, its arrow flipped. Memory would no longer look backward but forward. Anticipation would feel
like recollection.
You would awaken each morning with perfect knowledge of what is to come, while the past dissolved into incoherence. Events would unfold exactly as before, yet your awareness would move in the opposite direction. From your perspective, entropy would appear to decrease. The universe would seem to rewind, though to an external physicist it would still march forward. The arrow of time in this vision is not an objective flow, but a paradox of the observer. The thought experiment is unsettling because it dissolves the boundary between physics and subjectivity. We want entropy to be external, measurable, indifferent to perception. But if the arrow is bound to observation, then time itself may be less an absolute feature of reality than a relation between the universe and the minds that inhabit it. What we call irreversibility might be as much about how we store memory as about how molecules scatter. Neuroscience supports this possibility. Memory is not a passive recording device. It is an active, entropic process, laying down traces in brain tissue by increasing molecular disorder. Synapses strengthen through irreversible flows of energy. Each recollection consumes metabolic fuel, altering the state of the brain. We cannot remember the future because it has left no mark. We remember the past because disorder has already carved it into us. Entropy's arrow is not only written in stars and galaxies, but in neurons and synapses. The observer does not stand apart from the arrow. The observer is woven from it. But here the paradox deepens. If observers are defined by entropy, then how could any consciousness exist in reversed time? If disorder decreased, would memory reverse with it? Would a reversed brain recall the future as naturally as we recall the past? Or would consciousness itself unravel, unable to function without irreversibility? Perhaps the arrow of time is not just the condition of physics, but the condition of awareness itself. Without entropy's increase, there may be no observers at all. Still, we cannot dismiss the possibility that perspective plays a decisive role. Imagine two universes identical in every physical way, except that in one, observers remember the past. In the other, they remember the future. From the inside, each group of observers would insist their arrow is the true one. From the outside, both are equally valid descriptions of the same events. In this sense, the arrow of time may be relative, not to velocity or position as in relativity, but to consciousness. Time does not exist without observers to divide it into before and after. This relativity casts entropy in a new light. It may not be a universal law, but a cognitive horizon, the limit of how observers register the flow of reality. If so, then reversal becomes a matter not of physics alone, but of perception. The universe could continue exactly as it does, while consciousness shifts orientation. From one perspective, entropy always increases. From another, it always decreases. Both views are true because truth itself is tethered to observation. Such speculation blurs the line between salvation and doom. If reversal occurs at the level of consciousness, it could mean liberation from the tyranny of time. To remember the future would transform existence, dissolving uncertainty, replacing fear with inevitability. But it could also mean suffocation. No choice, no surprise, no freedom. Life would become a script already known, each moment predetermined. The paradox is that observers may be trapped by entropy not only physically but existentially. We cannot escape the arrow because we are The arrow cosmology adds another twist. Some theories suggest the universe may harbor regions where entropy flows in opposite directions. If observers arose there, they would perceive us as reversed, just as we would perceive them. From our perspective, their memories would point to what we call the future. From theirs, ours would point to theirs. The clash of arrows reveals that time may not be global at all. It may be local, tied to the entropic conditions of each region and to the observers who emerge within them. The paradox of the observer is that each insists their arrow is absolute, yet none can prove it. So where does this leave us? Perhaps with humility. Physics seeks objectivity, yet entropy forces us to confront subjectivity. Time may not be a property of the universe independent of us, but a co-creation of cosmos and observer. We measure disorder rising, but only because we ourselves are written into that disorder. Our sense of past and future, our memories and hopes are not windows onto an external law. They are the embodiment of the law itself. And so the forbidden question grows stranger. Can entropy reverse? From the standpoint of physics, perhaps only through rare fluctuations or cosmic recurrence. From the standpoint of the observer, perhaps always depending on perspective. Reversal may not require the universe to change, only the consciousness within it. Time's arrow might not break, but our experience of it could flip, revealing that what we call inevitability is only viewpoint. This is the paradox. Entropy feels objective, but depends on observers. Observers feel independent, but depend on entropy. Neither can be separated. To ask about time's arrow is to ask about ourselves. The universe may not be bound by irreversibility, but we are, or perhaps we are not. Perhaps in some hidden dimension of consciousness, we already perceive both directions at once. The paradox of the observer does not resolve. It leaves us suspended between physics and philosophy, between objectivity and subjectivity. But it illuminates a profound truth. Time's arrow is not only about stars and galaxies, it is about memory, perception, and the fragile architecture of identity. To confront entropy is to confront ourselves. And perhaps when we do, we will find that the arrow of time has never truly existed, except in the eyes of those who watch it pass. The silence beyond reversal, what lies beyond the arrow of time. We have imagined rebirth, resurrection, cycles, and salvation. We have conjured visions of stars reigniting, civilizations restored, and lives replayed. But what if all of these dreams are illusions, shadows cast by a deeper truth? What if true reversal of entropy does not bring renewal, but erasure? What if the undoing of disorder also undoes meaning, dissolving the very fabric of story, choice, and identity? Entropy's increase is painful, but it provides coherence. Because disorder rises, events arrange themselves in sequences we can follow. Causes lead to effects. Memories build upon themselves. Anticipation has a place to point. The arrow of time may wound us with loss, but it also grants us narrative. It gives life a beginning, a middle, and an end. Without it, we would not know what it means to exist within a story. Now imagine entropy running backward in earnest. Imagine cause and effect collapsing, not into reversal, but into indifference. The glass unshatters not because of choice, but because of inevitability. Wars unfight, not because peace was made, but because the script demands retreat. You fall in love not through freedom, but through predestination written in reverse. The moment order begins to overtake disorder, meaning begins to collapse. Each event no longer stands on its own, but becomes a puppet pulled by what must be undone. At first, reversal looks like healing. Ruins rebuild, the dead rise, youth returns. But healing without cause is not healing at all. It is erasure. The scar that once told a story of survival vanishes into blank skin. The memory of grief disappears along with the joy that came after. What made the moment precious? Its irreversibility is gone. In reversal, everything returns, but nothing matters. We long for renewal, yet renewal without narrative is emptiness. If entropy truly reversed, then our sense of progress, our hope for the future, our memory of the past would dissolve. What we call identity would unravel into incoherent fragments. The you who remembers childhood would no longer exist because memory itself would lose its anchor. The you who chooses would no longer act because choice requires uncertainty. In the silence beyond reversal, the scaffolding of existence collapses. Consider how deeply our lives are tied to irreversibility. Music moves us because notes follow one another, never to repeat the same way again. A melody reversed is not the same song. Its emotion vanishes with its direction. Stories grip us because events unfold. Decisions matter. Consequences cannot be withdrawn. Reverse them, and the plot dissolves into nonsense. Life itself is a story only because entropy grants it shape. Take that away, and what remains is not eternity but incoherence. This is the hidden terror of entropy's reversal. We imagine it as a gift, but it may be a void. Renewal without meaning, existence without story, identity without self. If order triumphs over disorder absolutely, then reality becomes static, frozen not in equilibrium but in cancellation. Every effect is undone, every cause erased, until the very logic of experience falters. What is left cannot be called life or death
or even time.
It is silent. Some philosophers suggest that meaning itself is born from entropy. We care because we know moments cannot be retrieved. We love because we know people will die. We strive because we know opportunities vanish. Mortality, fragility, impermanence. These are the conditions under which significance arises. Reversal threatens all of them. In a cosmos where everything returns, nothing is truly lost, but nothing is truly valuable. Immortality of this kind is indistinguishable from emptiness, and yet we yearn for it. We dream of worlds where no moment slips away, where no story ends. Perhaps this yearning is not for salvation, but for release from the unbearable truth of entropy, that meaning and loss are bound together. To wish for reversal may be to wish for the undoing not only of pain, but of meaning itself. We seek order, but order without entropy's shadow is hollow. Cinematic imagery makes the point stark. Imagine a library where every book is being rewritten backward. Pages fill themselves with letters, then letters vanish into blankness. Characters unspeak their lines, plots unthread into incoherence. The library remains, but its stories dissolve into silence. This is reversal, not a gift of restoration, but the quiet annihilation of narrative. So too with the cosmos. A universe in which entropy recedes would not be a universe of triumph, but of unraveling. Stars might reignite, but their light would no longer illuminate progress. Civilizations might return, but their histories would no longer mean struggle or achievement. Individuals might rise from death, but without memory, without continuity, without choice, what would they be? Not persons, but mannequins of inevitability, puppets pulled along the backward tide. The silence beyond reversal is cosmic unease. It reveals that what we fear in entropy is not disorder itself, but the price of meaning. Disorder gives us time, story, identity, and purpose, even as it robs us of stability. Order without disorder strips all of these away. To undo entropy completely would be to undo significance itself. This thought leaves us suspended. Do we prefer the pain of irreversibility, where we lose what we love but know that our lives matter? Or do we prefer the stillness of reversal, where nothing is lost but nothing is meaningful? Is salvation worth the annihilation of narrative? Is immortality worth the erasure of self? The question has no easy answer. Perhaps there is none. Perhaps the human mind cannot imagine existence stripped of entropy without also imagining meaning, and so we confuse reversal with renewal. But the silence beyond reversal suggests otherwise. There may be no renewal there, only emptiness, no story, only noise, no life, only erasure. And yet, the very unease of this thought may be its gift, for it forces us to recognize the fragile miracle of our condition. We live in the narrow window where entropy flows forward, carving meaning into each moment, giving coherence to memory, depth to love, urgency to choice. We live in a universe where disorder rises, and precisely because of that, our stories matter. The silence beyond reversal is not our world. Our world is alive with impermanence and therefore alive with meaning. The forbidden question, can entropy run backward, ends here in a paradox. It can, in principle. It may, in infinity. But if it does, it may not bring what we seek. The end of disorder is not the triumph of order, but the collapse of significance. Beyond reversal lies not salvation, but silence. And in that silence, perhaps, the universe whispers its most haunting truth. We are fragile, finite, impermanent, and because of that, we are meaningful. Beyond the arrow, we have traveled far. From the shattering of glasses to the death of stars, from the myths of eternal return to the paradoxes of quantum law, from the fragile memory of the brain to the dizzying speculation of simulation, we have followed entropy's arrow through
every scale of existence. We have dreamed of reversal as salvation, and we have feared it as doom.
We have imagined rebirth, resurrection, cosmic cycles, and absolute silence. And yet after all this, the question still stands unresolved. Perhaps entropy reversal is not about time running backward at all. Perhaps it is about transcending time itself, breaking free not from disorder, but from the very framework that divides past from future. Entropy gave us narrative, beginnings and endings, causes and effects, memory and anticipation. It gave us history, progress, tragedy, and triumph. Without it, there is no story. But as we've seen, the arrow of time may not be fundamental. At the quantum level, the laws are symmetric, blind to past and future. In cosmology, reversals are mathematically possible. In philosophy, cycles haunt our imagination. Everywhere we look, irreversibility seems less like an absolute law and more like a condition of our perception. What if the arrow of time is not the bedrock of reality, but a lens, a temporary scaffold, something we inhabit, but not something eternal? This is the final paradox. Entropy's reversal may never truly be about rewinding the film of the cosmos. It may never mean ashes leaping back into flame or civilizations rising exactly as they were. Instead, it may point to a deeper transformation, the collapse of the distinction between forward and backward. Reversal, in this light, is not running the story in reverse, but stepping outside of the story altogether. Beyond the arrow, time itself may dissolve into a symmetry we cannot yet comprehend. Consider again the quantum world. Its equations know no arrow. They permit events to unfold in both directions with equal validity. Only when we, the observers, carve probabilities into certainties does an arrow appear. What we call irreversibility may be the shadow cast by consciousness upon symmetry. If so, then to transcend entropy's arrow is to transcend the very conditions of observation. It is to imagine a perspective beyond memory, beyond anticipation, a view not within time, but outside it. From such a vantage, entropy's increase and decrease would be indistinguishable. Disorder and order would be two faces of the same coin. Past and future would merge into a single, timeless reality. This thought unsettles because it robs us of the anchors we cling to. What are we without story? What is existence without before and after? To say that reversal transcends time is to say that meaning as we know it may not survive. Yet perhaps this is not annihilation but metamorphosis. Just as the caterpillar cannot imagine the sky that the butterfly inhabits, perhaps we cannot yet imagine the kind of existence that lies beyond the arrow. Myth intuited this possibility long before physics. The Hindu cycles of creation and destruction, the Stoic conflagrations, Nietzsche's eternal recurrence, all suggest that time is not linear but circular or infinite. Yet even these visions remain trapped within the framework of time. Cycles repeat, histories recur, ages return. To transcend the arrow is stranger still. It is not cycle, but collapse of cycle. It is not return, but release. The myths hinted at eternity, but physics now suggests eternity may not resemble endless time at all. It may be something beyond our categories, beyond narrative itself. Cosmology offers a glimpse. In some models, the universe may not have a singular beginning, nor a singular end, but a space-time structure where time as we know it emerges only locally. From another vantage, one not bound by entropy's arrow, the universe may exist all at once, a totality without before or after. The Big Bang and the heat death would not be points on a timeline, but features of a whole. Entropy reversal in this frame is not an event but a shift of perspective. The end and the beginning are not opposites, but different windows on the same eternal structure. Neuroscience too hints at this. Our consciousness stitches reality together moment by moment, constructing the illusion of flow. But beneath, perception is discontinuous, fragmented, always catching up, always editing. The arrow of time in the mind is already an invention, already a story imposed on experience. To transcend entropy's arrow, then, might not mean the universe changes at all. Only that consciousness awakens to its own invention. Time, as we live it, would dissolve. What replaces it may be unimaginable, but perhaps it would feel like release. Yet the human heart hesitates. We crave story. We yearn for narrative arcs, for beginnings and endings, for victories and losses that matter precisely because they cannot be undone. To abandon the arrow feels like abandoning ourselves. But perhaps the final question is not whether entropy can reverse, but whether we can imagine existence without needing it to. Can we see beyond the arrow without despairing? Can we accept that meaning itself may be conditional, real within the arrow, but not beyond it? Cinematic imagery presses this point. Picture the universe at the moment of heat death, silence, darkness, equilibrium. Now picture one spark of reversed light, a photon moving backward, igniting order where none should exist. To us, this would look like miracle, resurrection, salvation, but to an intelligence beyond time, it would not be miracle at all. It would be symmetry revealing itself. The end and the beginning, indistinguishable, folding into each other like two sides of a page. Perhaps that is the true meaning of reversal. Not the undoing of time, but the revelation that time itself was never ultimate, that the arrow was always provisional, always emergent, always a veil. Perhaps the final question is not whether entropy can run backward, but whether we can awaken to a cosmos where backward and forward no longer apply. This leaves us in awe and unease at once. Awe because the universe may be vaster than narrative allows, encompassing both our stories and their dissolution. Unease because in transcending the arrow, we may lose the very things we cherish: memory, identity, freedom, progress. Yet perhaps even these are not destroyed but transformed. Just as order emerges from disorder, perhaps meaning emerges from impermanence. And just as entropy can in principle reverse, perhaps meaning itself can transcend. So the journey ends where it began, with a forbidden question and with imagery that defies comprehension. Can entropy run backward? The laws of physics allow it, at least in principle. The mathematics suggests it, myth intuited it, philosophy wrestled with it. But perhaps the deeper truth is that the question itself is limited. Reversal may not be about physics at all, it may be about perspective. It may be about stepping outside the arrow to glimpse reality as it is, timeless, whole, beyond our categories of order and disorder, past and future. And so we close with wonder. Imagine the cosmos as a silent stage, emptied of stars, stripped of story. Then, in that silence, a flicker, not of resurrection, not of cycle, but of something stranger, a spark that reveals the end was only the beginning in disguise. The final question is not whether entropy reverses. The final question is what lies beyond the arrow itself.